This illustration deals with individual circuits that have a combination of loads, such as you see in the illustration. We have lights there, and we have non-continuous load and two non-continuous loads of 3 amps each, and we have 11 amp continuous load. The conductors are THW and copper conductors, and we have an overcurrent device ahead of this branch circuit. Now, before we dig into this too far, let's look at the note. The note states for calculation ampacity, see 210.19A1A to size the conductors, 210.20A to size the overcurrent device. If it happened to be a feeder involved, you'd look at 215.2A1A along with 215.3 for sizing the overcurrent device. If you're sizing service conductors, you'd look at 230.42A1 along with 230.90 to size the overcurrent device. Now, the figure loop says, hey, if you want more information concerning what we're fixing to calculate and look at, see figures 14-16, 14-17, and 15-12 in Volume 2 of Design, Stallcup's Electrical Design Book, if you wanted to get deeper into a variety of calculations from service conductors to feeder conductors and branch circuits as well. But now, with the information of two 3 amp non-continuous loads and one load or number of lighting units maybe, but we have 11 amp continuous load. Now, we, again, a little repetitious here, but Article 100 defines a continuous load when the load can operate 3 hours or more without interruption. If it's less than 3 hours operation, then it can be considered non-continuous by the definition in Article 100 of continuous duty. Now, with that thought in mind and with this information, let's move to the calculation and determine the size of the conductors as well as the overcurrent device based upon both loads that you see in the illustration, one continuous, one non-continuous.